I've briefly touched on the fact that I wanted to design this in such a way that it can be broken down into its core components and be as recyclable as possible. So in this table, you can see every single material, where it came from, and where it will go once it's no longer part of this. For the clips, I used aluminium 6061. This is a type of aluminium alloy which is mixed with silicon. You can buy this already from a recycled source because where does it go? It is infinitely recyclable. You can constantly melt and remold aluminium 6061. Same as the material for the case, steel aluminium alloy. You can also get this from the UK, from a recycled source, and when you're done with it, it is infinitely recyclable. The silicone in the grips, you can buy from the UK, but you do have to buy it brand new, because if you buy it used, it's not going to be of the same grade and strength that it is brand new. But it is partially recyclable in the sense that it can't really be remolded into anything specific, but it can be an ingredient in what we call mulch, which can be used as astroturf in places like children's playgrounds, for example. The acrylic can come from a recycled material from the UK. However, it is only finitely recyclable. You can't recycle it forever. Eventually it will be too weak to do anything with. The electrical components though, 50% of them come from East Asia, mainly China and Japan, and the other 50% were unspecified from the sources that I got them. All of them are brand new. And they're partially recyclable. They're a PCB board that when you recycle, you can extract some amount of copper oxide, tin, and with the right machinery, even some of the gold and silver that's inside them. The software that you have available is a range of open source and paid APIs and environments to develop an accompanying app for this device to really boost its potential. For example, Google Speech to Text charges approximately $1.5 per hour of talking that it converts from either text to speech or speech to text. iTranslate charges approximately $15 per million characters translated. iTranslate is just one example of an API that can translate between many different languages. Android Studio can be used to develop Android apps. Apple Developer can obviously be used to develop Apple apps. To give you a brief demonstration of how I envision this translation feature would work, obviously you're going to need a microphone, which is at the top of the front there, and you need a speaker, which is at the bottom of the back. In this case, you're translating from German to Korean because you've set it. If you wanted to change that, you could click on the swap button in between the two flags. But if you just want to translate from German to Korean, you would hold down on the microphone button underneath the second screen whilst on this setting. And in this case, you would say Guten Morgen, which in German is good morning, which would translate to Korean, which is Chun Achimayo. And also, please don't be fooled into thinking that I can speak either of these languages. I can't. This is just for a demonstration purpose. Thank you. So as mentioned, we don't want to spend all of this money on a device that has the potential to do more than it actually does. So what you can do with this device, as well as it being a translator, is that you can use it as a torch. It can tell you the weather. You can attach your earphones to it and you can listen to music. You can use voice activation. You can use it as a compass. It's a flash drive. It's an alarm. And it also hangs around your neck. You don't need to worry about dropping it. You could use a wrist lanyard. You can take it anywhere. this device is reliable. Therefore, a good question that you might have at this point is, with all of these additional features, how much does it actually cost? Well, first of all, it's cheaper to buy in bulk. So we're going to assume that we're buying enough parts for 100 units because you get all of the parts cheaper individually. So of the components, you're paying £40 per unit. This actually breaks down to, in the above £10 range, you've got the screens. In the £5 to £10 range, you're paying for the main board and the battery. In the £1 to £5 range, you're paying for the SD card, the SD card reader, all the LEDs, the touchpad, the speaker, the wires, and the aux jack, and everything else is under £1. For the materials of this, that's £5 per device, with the silicon costing 40p, the steel in the main case costing £2.63, all of the aluminium for the clips costing 35p, and a total of 60p for the acrylic. Based on an estimation using AutoCAD Fusion 360 and Print City, less than £5 per unit to manufacture all of these special parts. Now for the human assembly and testing, assuming that the worker that's assembling them after training is paid £8 an hour and can produce 2 an hour, that's £4. For the software, we don't know because we need a consultation. We don't know how much an app is going to cost. We don't know which APIs we're going to use. So for the purpose of accuracy, I'm only going to base the price on the components, materials, 3D printing, and human assembly and testing. To summarize everything just mentioned then, for one unit, the initial cost is approximately £55. Now what this means is that if you sell it for a retail price of $69.99, you will have a 27% markup. For $79.99, a 45% markup, and for $89.99, a 64% markup. Now this markup should adequately cover the advertising, the software development, the wasted materials, and leave a sizable profit. Also worth mentioning that the estimated weight mass is 258 grams. This is good because with a 64% markup at $89.99, it's under the goal of £100. And with a mass of 258 grams, it's under the goal of 300 grams, which is everything that I set out to do in my design. So to conclude, and I'll try and keep this brief, everything has its pros and cons. In the interest of a fair assessment, I won't ignore the cons. This needs further development. It doesn't have an app yet, and there's no quote for an app. It doesn't have an internal frame to actually attach the components to the device. The only reason they were in the demonstration of how it's assembled is to show that they can actually fit inside, that there is enough room for them and that there is enough room for the wiring, which of course it also doesn't have. So it does need further development. And it is also reliant on a phone still. This doesn't have a camera. If it needed a camera, there is no more space currently for it to be included on the bottom, which is where it would make most sense to put it. So the mainframe would need to be elongated and it would have to be worked out around that. And this is exempt for legal translating because there are too many laws in place saying that for someone to be read their legal rights and information, it has to be a human translator. In some cases, it has to be two to make sure that there is honesty, that there is reliability in what is being said. So this will never meet that standard. This is only for casual conversation when traveling through somewhere. Pros. There is a lot of software potential. This hardware, with it being a dual-core processor, with it having 8 gigabytes of storage, with it having a speaker, a microphone, lights, screens, it's a very adaptable device to new updates, new software, new functions. It doesn't have to just stop at being a translator with the, aforementioned functions. It's an adaptable design. The model that I've made can quite easily be extruded to add more sensors, more actuators, and it's multi-purpose. It's a torch, it's a speaker, it's an alarm, a storage unit. It's just a lot more than simply a translator. Considering the materials that it's made of, it is lightweight. It's made of steel and it's less than 300 grams. It has safety features. It could be an essential part of someone's well-being, considering that it has a lanyard so that it's not going to go anywhere. It has a torch and an alarm in case someone is in a dangerous situation. And it's user-friendly because anybody can use it. Children can use it, disabled people, elderly, people of all languages, visually impaired people because the buttons can quite easily be made braille, deaf people or hard of hearing people, as it does have a screen that can read what someone is saying in certain functions. And it is strong and resistant to the elements. It's water resistant and it's trauma resistant. So that's my design, and thank you for listening for the last 25 minutes. I hope it hasn't gone on too long, but yeah, I've worked on this for a few weeks now and I've enjoyed doing it. So thank you for listening, it means a lot.